Hello everybody. Today we're learning about permutations and combinations. The essential understanding says that you can use multiplication to easily count the number of ways certain things can happen. And to do that we have a fundamental counting principle. And what this says is that if there are two events that can happen m and n different ways, respectively, then there are m times n ways the combination of the two can happen. Now this is dealing with combinations, and one thing about combinations is the second event doesn't really care about what the first event is doing. So for example, if you are trying to pick out an outfit to wear and you have 3 pants and 2 shirts that you can wear, this gives us 3 times 2 possible outfits, so 6 possible outfits. And here's why it works. If we choose the first pair of pants, we can still choose shirt 1 or shirt 2. So there's 2 different combinations right there. So if we choose the second pair of pants, we can still choose shirt 1 or shirt 2. So there's 1, 2, 3, 4, and then pants 3 will give us 2 other combinations. So again, I need to stress that this combinations does not, the second event or third event does not care what the previous events are doing. Okay, so here's our first problem using combinations. So in 1912, Maryland license plates had places for 4 digits, 0 through 9. In 2004, they changed the plates so there are places for 3 letters, A through Z, and 3 digits, 0 through 9. So how many more possibilities do the 2004 license plates have? So if we look at the number of license plates the 1912 license plates offer, we have 4 different choices or 4 different places or types of combinations. And in each one we can pick 0 through 9. So that gives us 10 different digits that we could use. So the second event, it does not matter what the first event did because it's still 0 through 9 possibilities or 10 different chances. So on each of the 4 we have 10 possibilities, 10 different numbers that we could choose from. So our solution would be 10 times 10 times 10 times 10, which would give us 10,000. For 2004, it says that there are places for 3 letters, so 1, 2, 3, and 3 digits, 1, 2, 3. Now, in the English alphabet, we know there are 26 letters, so 26, 26, and 26. Again, the second doesn't depend on the first, the third doesn't depend on the second. So each one we can choose A through Z, so there's 6 different options in each. And then the 3 digits all have 10, so we're going to multiply all of those as well. And when we multiply those all together, that would give us 17,000 or 17,576,000. And so now all we need to do to find how many more is subtract the 1912 from the 2004. So it would subtract 10,000. And so that would give us 17,566,000 more license plates. Not too difficult. Okay, so here is the first problem that I would like for you guys to work on yourselves. So pause the video, try to work it out, and once you get done with it, press play and you can see the solution. So this problem says in 1966 there was a type of license plate that had 2 letters followed by 4 digits. How many possibilities did that have? Well, if we have 2 different letters, we know that that's 26 times 26 followed by 4 digits. Well, we know there's 10 different digits. So there's 4 of those. So when we do that, we could get 6,760,000. And that's it. So the first example was talking about combinations. But here we're going to start talking about something called permutations. And what this is an arrangement of items in a particular order. So remember how I was saying in combinations that the second event did not really care what the first event was doing. They were independent of each other. Now here, permutations, this means that the second event is dependent on what the first event is doing. Then the third event is dependent on what the first and second events are doing. So for example, let's talk about this. How many ways could you reorder the letters A, B, and C? And this is a permutation because to reorder these three letters, you have to pick one first. So if we picked A first, the only two letters that would be left are B and C. So then if we picked B second, then there would only be one left. So the first letter that we picked, we'd have A, B, or C, so three choices. The second letter, we'd only have two choices. And then the last letter, we'd only have one. So here I did this, and this might be one way you guys thought about doing this problem. Writing it out as many times as you can. You can see that there's 6 different possibilities. Well, again, there's another easy way to count this number of permutations by using multiplication. Well, again, the first letter that we picked, we said that there are 3 different letters. You could pick A, B, or C. So there's 3 different options. But after that first one, if you picked A, there's only B or C. If you picked B, there's only A or C. And if you picked C, there's only A or B. So the second choice you had, there's only 2 letters. So we would have to multiply it by 2. Then on the third choice, after you've picked 2 out of the 3 letters, there's obviously only 1 letter left. So we could multiply that by 1. And if we did that, 3 times 2 times 1 would give us 6. And so we can do this with other types of permutations. If you noticed in that example of a permutation, we had to multiply 3 times 2 times 1. And if you notice, that's pretty much like counting backwards and then multiplying by them. And that has a special notation. And we call that what's called as factorial notation. And we show that as n factorial. Well, it's an n with an exclamation mark after that. And what that means is we take whatever n is, and we multiply it by 1 less than n. And then multiply that by 2 less than n, and so on until we get it to be 3 times 2 times 1. So for another example, if we were to do 4 factorial, that would mean to start with the 4 and then multiply it by 1 less each time. So 4 times 3 times 2 times 1, and we would get 4 times 3 is 12 times 2 is 24 times 1. So that's 24. Like we saw earlier, 3 factorial would be 3 times 2 times 1, which is just 6. Okay, let's do one more, 5 factorial. Well, that means starting with 5 times 4 times 3 times 2 times 1. And we would get 120. So that's what factorial is. And we're going to use these when we deal with the permutations. Alright, so another example of permutations is this problem. So let's try to find how many ways could you order 12 students. So we have 12 students in a class and we want to order them. Well, the first one, we could order them alphabetically. But that doesn't even matter. If we have 12 students, we can factor it or order them 12 factorial times. So what that means is we could do 12 factorial, which is 12 times 11 times 10 times so on, all the way down to 3 times 2 times 1. Now, instead of multiplying 12 times 11 times 10 times 9 times 8 and so on, our calculator does have a button that we can use to help us figure this out. So if you hit the math button and you scroll to the right 3 times to the file that says PRB, and you scroll down to option number 4, there's your factorial sign. So how to use that, you're going to hit 12 and then you're going to hit that factorial sign. So PRB after you hit the math button and scroll down to number 4. And 12 factorial is going to be a rather large number, which is 479,001,600. So there's quite a few ways that we could order a class of just 12 students. Next, we're going to look at the number of permutations of a certain amount of items of a set arranged are items at a time. And so we look at how this looks. It says N P of R. So this is the number of items total, and this is how many items we're going to take at a certain time. And so it's going to be the n factorial over n minus r factorial. And so to illustrate this property, it's easiest to see an example. So for our problem 3, it says that 10 students are in a race. First, second, and third places will get medals. In how many ways can the medals be awarded? Well, if we have 3 medals, how many runners could you give first place medal? Well, if you're starting off, you know there's 10 runners, well, so that'd be 10. So after that, after we've picked one person, how many are left? Well, 9. And then thirdly, you could have 8. Well, if that's it, there's only going to be 3 medals given out, so 10 times 9 times 8, that will give us 720. So there's 720 different ways that we could hand out 3 medals. Now, if we want to use the formula, the permutation formula that we just talked about right here, we would set it up as NPR. Well, N is the total number of items. Well, this is the 10 runners or racers. So this is 10 permutations, and then the R is going to be how many items taken at a time. Well, since there's 3 medals, that would be 3. So the way we would set that up, it'd be n factorial or 10 factorial over n minus r, 10 minus 3 factorial. So now let's see how this works. We have 10 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, now 10 minus 3 is 7, so we would have 7 factorial in the denominator. So this would be 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you notice, everything from 7 on down will cancel each other out. So these all cancel with everything here, and so we're left with 10 times 9 times 8, which is just what we did in method 1, which would give us 720 again. Alright, so we talked about the formula for the number of permutations. Here's the number of combinations. Now this is similar to permutations, but it's, I think, a little bit easier to think of. So our last example, we talked about giving 3 kids 3 different medals out of 10 different runners. Now let's say you were really cheap and you didn't want to buy 3 different medals. Let's just say you wanted to buy spoons. 3 spoons that are exactly the same. And first, second, and third place runners get the 3 spoons. All 3 of them going to be equally disappointed, but they're not going to be able to tell the difference. So when you think about combinations, the order does not matter. It doesn't matter who we give the first spoon or the second spoon or the third spoon because they're all 3 the exact same. So let's do an example real quick. So let's say we had 5 people and we wanted to give them 3 spoons. So if they had to race, first 3 got spoons, the other 2 got left out. So notice if we took out this factorial or the r factorial, that is the same as permutations. Okay, so what we do is we just basically divide out the redundancies. So this r is how many redundancies. Well, if we have 3 spoons, that's 3 redundancies. Okay, so what we do is set it up 5 factorial over r factorial, which is 3 factorial, times 5 minus 3 factorial. Now this can simplify as well. Notice over here I've worked it out a little bit. 3 times 2 times 1, well, these factorials cancel each other out a little bit. And so now we have 5 times 4, which is 20, over 2 factorial, which is 2 times 1, which is just 2, and so that will reduce to 10. So here's another example for combinations. If we read the problem, it says, how many different ways can 3 silver spoons be given to the first 3 finishers of a race with 10 people in it? So if we look at it, there's a total of 10 people. There's 3 silver spoons, so we're trying to give out 3 of these silver spoons. They're all identical, so they all suck the same amount. Now, if we give them out, this is a combination because it doesn't really matter which order you're going to be given. If you finished first in a race and given a silver spoon, you would be just as equally disappointed if you got second in the race and you got that same silver spoon. So here the order does not matter. And so this tells us that we're using combination. So the number or total amount of people is 10. So that's the total combinations. So I'm going to say the combinations is taken of 10 people, taken 3 at a time. It's because we have 3 spoons that we can give them that are all redundant. Okay, so that's going to be n factorial. Well, that's my total number. So 10 factorial over my redundancies is the 3 silver spoons. So redundancy is the R. So 3 factorial times, and then I have the total minus the redundancies. So 10 minus 3 factorial. Okay, now the way that I like to simplify this is we can look what's inside the parentheses. We have 3 factorial times 10 minus 3 is 7 factorial. And if we work this out, the 10 factorial is 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1, 0. And then we'd have 3 factorial times the 7 factorial, which is 7 times 6 times 5, and it would go all the way down to 1. So all these, the 7, 6, 5, 4, 3, 2, 1 up top, would cancel out with the 7, 6, 5, 4, 3, 2, 1 on the bottom, and we'd be left with 10 times 9 times 8, which would give us 720, over 3 factorial, which is 3 times 2 times 1, which is 6, and we do 720 divided by 6, and that would give us 120. So we'd have 120 different possibilities of giving 3 different people spoons here. Thanks for watching. I hope this helped you out with permutations and combinations. Now go have fun with your homework.